Hey guys, welcome back to 0xHackMeetup. Today with me is Paweł Zaremba, who is a software engineer at ChronicleLabs and the Oracle core unit at MakerDAO.
Exactly.
Welcome, Paweł.
Thanks.
We're gonna also have a presentation from Alex from Redstone. Paweł is gonna give us an introduction to oracles and give us a wider overview. He's gonna talk about smart contracts. And Alex is gonna do a smart coding session and talk about the project he's working on, which is redstone.finance. So yeah, without further ado, Paweł,
Thanks.
the floor is yours.
Let's go. So there were some spoilers here, but okay. So as we've heard, I'm Paweł, and I'm gonna tell you about oracles. Maybe. Oh, there it is. Yes, I'm going to tell you about oracles. So the first question you might have, what are oracles? So this, no, not about this today. And also some of you may know this movie, and this is the oracle from Matrix, but also not this. It's not going to be the topic of our discussion. This is a representation of mythical oracles, which is almost the thing we're going to talk about, but not exactly. And blockchain oracles are exactly what we are going to talk about. So both mythical oracles and blockchain oracles know the truth. That's the idea behind oracles. They tell it to anyone who asks, and sometimes require sacrifice in the case of mythical oracles, and some payment may be in case of blockchain oracles. But first, let's talk about the oracle problem. What is it, and why do we actually need oracles? So we know that blockchains are very nice and we love them because we are working with them every day. They are immutable and secure. So no one can change the data, and we always know that once verified, the data is stored and secure. But they are also isolated. The problem with isolation is that we cannot, the blockchains, but by themselves, don't have any ability to contact the outside world. And we have a lot of data outside of blockchains. And we want this data inside blockchains so we can operate on them and write, for example, smart contracts that do something with it. So anyone claiming that they have solved the oracle problem is full of assumptions, let's say. Because, for example, who are we going to allow to update the oracle? Let's say we have a smart contract on the blockchain side, and we allow someone with a specific key to update the values of the oracle, for example, price data. Let's say the price of ETH or price of something else, pen, pineapple, apple, or something else. So the problem with having only one person update this oracle is trust. We don't want to trust only one person. That's why we built blockchains in the first place. Then we can have multiple feeds, multiple people that are updating the oracle contract but here there's also a problem. How do we know which update to take, and how do we know if someone is actually not genuine with this, with their information? That's why we need some kind of conflict resolution. So to resolve these conflicts, we implement some kind of consensus mechanism. For example, with prices, it is very common and usually projects implement a median. They take the values from multiple feeds. They then calculate the median value, and that is stored on chain as the actual price for this period of time. But this actually, at least with the current gas prices, is very expensive, because having this median calculation done separately for each feed means we have multiple transactions that need to be verified, and then this costs a lot. So what we could do is actually introduce a third-party relay that gathers all the information from the feeds that post data about prices or anything else, actually. And we let only one entity post data on the blockchain. But this, on the other hand, introduces us to a different problem, which might be censoring. So the single relay that we implement can be censoring other feeds. So we need something more sophisticated, let's say. So we try to decentralize the relays also. So we have multiple feeds on one side and multiple relays on the other side. And each of this relay has all the data that other feeds have provided. And at least one honest relay is enough to make sure that we post the data to the blockchain and no one is censored. Because, and of course, projects need to incentivize positive behavior and maybe use some kind of slashing or something if someone posts not proper data. So first we have the off-chain side, which is quite important. And for example, we can have a feed that communicates through a peer-to-peer network with relays. With this is a signed price message, an example from a signed price messages in the Maker oracles. As you can see, we have the type specified, we have the version of the software used, we have the price, and then we have some hex data, and we have a hash, and the signature of the feed that has actually created this message. And I will not be going into the detail of the off-chain side today, because there's a lot of it. And if you would like to see the software that is actually doing it for Maker protocol, you can go to these addresses. So first, Oracles v2 is the second iteration of oracles that were implemented by Maker. And it's an orchestration tool, let's say, that utilizes other projects, other software to create the whole Oracle system. So we've got Omnia, which is the software for feeds and relays, and we've got the Oracle Suite, which is a re-implementation of this software in Go, and also it has a very modular structure, so any project could actually be using some parts of Oracle Suite to use for their advantage. And on the chain side, so we have smart contracts that need to realize a few functions. So we need to make sure that only some trustworthy feeds are posting data to the chain. So smart contracts needs to have some kind of authorization. Then we have the consensus protocol. Of course, in the case of prices or other numeric values, it's usually common and makes a lot of sense to use a median of the values, because any outliers, any values that go way beyond what we would consider correct value will actually be filtered out by this kind of consensus. But we could actually implement something else. We could implement, let's say, a majority vote for some values that are not so easily quantifiable. So feeds could actually attest to something that happened, a fact, from any domain actually. And then the consensus method would be to have a majority vote from the feeds and to choose that to store in the Oracle. And one additional step is crucial for most projects. The step is delay. Usually when feeds post data to store it on chain, it's immediately accessible by anyone and anyone can use it. But since we have very volatile prices of most of the assets on blockchains, it is actually not a very good idea to use this value directly, because this data about prices is actually public. So anyone can take it, put it together with a transaction that actually does something with this price, and they can use and front run the protocol or some other projects with the data they have off chain, and then they can use it together with some other functions that they can call on contracts. So, for example, if a price falls very rapidly, but this is due to some tampering with the prices on the feed side, having a delay always is a last resort, and you could stop the project for actually being rug pulled or something in time. So usually it is a good idea to have a delay implemented within the whole Oracle system to be able to counteract these malicious behaviors. And Maker implemented median and the delay in Solidity. The first is available at this address. So this is the medianizer, the contract that takes all the values provided by feeds, verifies that they were actually signed by allowed feeds, and then stores this data. And OSM means Oracle Security Module, which actually introduces this delay. So let's go into code. This is a Solidity contract for the medianizer. We can ignore the libnode class because it's just a small detail that we are not concerned about right now. But as you can see, the median contract has some authorization methods and fields which are utilized to control who can write and who can read to this contract. For example, we have words that determine who is the admin of this contract, so who can change values like parameters in it. And also we have a list of oracles so these are the feeds and their public addresses that we allow them to push the data to our medianizer contract. And then we have addresses of contracts that can read from the median contract. So as you can see here, we have a modifier that's called toll. So we require the message sender to be in the list of the buds or buddies, and if not, the transaction will be reverted. And then we have the whole update function. It's called poke. By the way, it's part of the Taiwanese language used in Maker protocol in multiple contracts, which means that, like, for example, many of the functions or most of the functions are 4-letter words. So we poke the contract to update the data. Let's quickly go through the whole function. So first, we require that the length of the array that we provide, so the list of the prices that we provide is exactly what we determined to be the bar. So for example, in Maker, the bar is usually at 13. So out of the 26 feeds that we have, we need at least half of them to be used in an update, so we can reliably determine the price for the asset. And then we loop through the whole list of prices with signatures, and we recover the address of the signer using a recover function, which I will talk about later. And then we require the signer of the message to be in the list of oracles. And we also require that every data point that we use to update the contract is actually younger than the latest Medianizer update. And then we make sure that the list is already ordered, so we can choose the middle value as the median of an uneven number of items in an array. And then we just store it. So we've got the two crucial parameter functions of Oracle here. So we verified that the data is correct and signed by allowed feeds, and then we determine the median. So this is our consensus, and we store it on chain. And now about recovering the signer address. So we've got a simple function that actually uses Ethereum's EC recover function, and it's capable, given the signature, which is divided into VRS parameters, given the signatures and the values that were signed, it's capable of determining who actually signed the list, this particular price. So then if we have this address, we can compare it with the array of with the list of addresses that are allowed to update the contract. And this part is used to introduce the 1 hour delay. We have defined some constants and some values, some fields that determine how long ago was the Medianizer updated, and then when we poke the OSM, I'm sorry. So when we poke the OSM, we updated the values into the security module. We take the current we set the current value as the next one, and then we set the next one as the value that has been provided in this update. So as you can see, we have implemented a way to make sure that we know in advance what price will the Oracle system as a whole show to the external contract to be used for anything they actually want. And this is a small dashboard that was created by the community of Maker, and it shows the Medianizer price as it is stored in the Medianizer contract, and then OSM price, the current and the next OSM price. As you can see, ETH was updated 8 minutes ago here, and for example, USDT was updated 133 hours ago. That actually is because we have disabled updating USDT because we are no longer using it. So if you have any questions, I'm open to them and looking forward. And this is a QR code for this presentation, actually. Do we have any questions?
We don't have any questions at the moment.
Very well. The only thing I would like to say is that, of course, as most of the projects. We are hiring. So if you are a backend developer, mostly in Go, or a smart contracts developer, or a front-end developer, just contact me and I will forward your call to whoever is responsible for handling that on our side. So thank you. I'm looking forward to any contacts from you. You can see my Twitter handle here and my blog address. There's nothing really up to date there, but anyway. So thank you very much, and hope to see you next time.
Paweł, thank you very much for this presentation. So we'll give the floor to Alex Suvorov from Redstone. Here we go. Hi, Alex.
Hi guys. Thank you for having me here. So, do you see my screen?
Yeah, great to have you. Yeah, we're gonna see it in just 1 second. Everything is working fine. So Alex is gonna give us some background on Redstone Finance, and then we're gonna do a live coding session. And then maybe Kuba Wojciechowski will gonna join us for the Q&A session. So for everyone watching, feel free to ask the questions in the YouTube chat or the Facebook comments, and we'll be answering them after this talk. So yeah, Alex, the floor is yours.
Great, thank you. Thank you again for having me here. I'm a software developer at Redstone, and today I'd like to tell you about the Redstone project and how we want to improve the blockchain oracles. As you probably know from the first presentation, a blockchain oracle is a third-party service that connects smart contracts on blockchain with the outside world, meaning providing data, like real-world data, to the blockchain smart contracts. And the main use case for oracles today is providing pricing data, because this pricing data may be used in lending markets, in decentralized insurance products, in liquidity aggregators, derivatives protocols, and even algorithmic stablecoins like DAI, and many more projects. There are a lot of ideas here. So pricing data usually are provided for cryptocurrencies and for fiat currencies, and sometimes for also stocks. But there are also like many ideas what kind of new data can be provided on chain. And the current most popular model, how blockchain oracles work, is that they post the pricing data to the blockchain regularly, for example, every 10 minutes, which has some advantages. Like this approach is quite easy to understand and easy to manage. However, it becomes quite expensive, and which leads to expensiveness of oracles in general and creates huge limitations. For example, in sense of that oracles cover really small subset of tokens and some small subset of assets in general. It also disables like easy ability to switch to the new blockchain. But today, new blockchain appears really often, and this approach needs to run a separate oracle instance for every new blockchain. Another problem, which is not connected to this approach, is that oracles are often centralized and prone to manipulation. All these problems resulted in more than $1 billion hacked and stolen from DeFi protocols that used blockchain oracles. And we at Redstone want to propose a solution, which we already implemented in some stage. And this solution has three main key points. The first one, that we don't want to use blockchain, like Ethereum blockchain, for storing the data, because Ethereum was not designed to store large data sets. Instead, we want to use cheaper storage that allows more data providers to come into the game. The second point is adding insurancy to DeFi protocols, in the sense that data providers will pay some stake that covers data reliability risks. And the third key point is that we want to create an accountable system with a permanent track of each record and each data that was provided by data providers. And how do we do this? In terms of cheap data storage, we want to leverage the Arweave blockchain, which actually was created to store large sets of data. It also has many other advantages, but even if we compare a cost of 1 gigabyte storage on Arweave, it costs only $35, while on Ethereum, it costs more than $1.5 million. So the second thing is managing the provider obligations and this insurance thing. And we do this through introducing manifests, which kind of describe what data providers need to provide, how often do they need to provide the data. And we do this currently as just a JSON file, which has designed structure. The second thing here is that, as I've said, providers need to pay some stake, which can be taken from them in case of wrong behavior, for example, providing wrong data or incorrect or not providing data at all because of, for example, technical problems. And this problem resolution or dispute resolution will be handled on using the smart weave contracts. Smart weave contracts are smart contracts built on top of the Arweave blockchain. They have a very interesting model of lazy evaluation, and we at Redstone see great potential in this protocol, and we also contribute a lot here. We've already implemented our own SDK for smart weave contracts, which is much more efficient than the original SDK. Because of caching and modular architecture, but it's a topic for a separate call, so I'll skip here and move to the third point, which is, I think, one of the most important here is, and the point is the efficient data access. And it's managed using this on-demand fetching. We call it something like on-demand fetching, meaning that we don't store the data on Ethereum blockchain or any other EVM compatible blockchain, but instead we provide the data on demand, and we provide the signed data so that they can be verified using the smart contract code, which we've already prepared. And another advantage that comes here is the compatibility with any EVM compatible blockchain like Ethereum, Binance Smart Chain, Celo, Avalanche, Polygon, XDAI, and others. And let's move to the architecture, and I'll try to give you a general overview how the whole Redstone protocol works. The core unit here is the Redstone node. It's something similar to blockchain node, but at this moment it doesn't communicate with other nodes, which will change in future probably. And the main thing that Redstone node does is fetching the data from multiple sources. Currently, we fetch data from more than 60 sources, including different exchange APIs like DEXs APIs and simply on-chain DEXs data. We also use standard cryptocurrency exchange APIs like Binance, Kraken, Currency.com, and many others. We also fetch data from Yahoo Finance website and European Central Banking API. And we fetch all this data. And the next thing that we do with this data is the data aggregation. For example, if we fetch data for Bitcoin price from 50 sources, we will take the median value. It's similar to this MakerDAO approach. But we do this already here. And we fetch the median value. And then we sign each data point separately because each Redstone node has its own private key. And it's used to sign each data point. And when the data is signed, we post it to the so-called data cache layer and to the Arweave blockchain. Posting data to Arweave blockchain can take about 20 minutes. So it's not really useful in terms of real-time data. That's why we also use this data cache layer. And data cache layer is currently our HTTP API. And we are also working on integration with Streamer, which is a PubSub decentralized network. And if users want to use the Redstone data, they will fetch them from this data cache, and they will be able to use, and they are able to use the data using this HTTP API in simple web integrations, even not decentralized apps, or in decentralized apps, but without the smart contracts. But they also can use the data using in smart contracts. And I'll tell you much more about this because we've implemented a special tool called Redstone Flash Storage that allows to integrate Redstone data in a very straightforward way. Just a few words what happens on Arweave blockchain also, because Arweave blockchain is used by Redstone to keep the data permanently and to manage disputes, because we also thought about this dispute resolution protocol, which is not implemented yet, but it will work on the smart Weave contracts. What is already implemented is providers registry, which is a catalog of providers and their manifests and their manifest history that can be managed by providers and can be displayed and viewed by any user that has access to our web application, because the web application is actually connected to the Arweave smart contracts and show this data that can be used and that should be provided by our current providers. So let's move to this Redstone Flash Storage thing, because I think this is the most important part of our solution. So when a dApp developer wants to use Redstone data in their smart contracts, they need to install an NPM module called Redstone Flash Storage and wrap the Ethereum contract instance, the JavaScript contract instance, using our special wrapper. And this wrapper will update the contract logic in the way that when the contract will send a transaction or will run a view function, we automatically will fetch the data from the Redstone API, fetch this signed data, and attach this data to the transaction, so that on the on-chain layer, the smart contract will be able to verify the data and use it in smart contracts code. And today I'll show you this on the live coding session a bit later. But one thing that worth mentioning is that we put really much effort to the Redstone Flash Storage optimization. And we can say that currently reading the data using Redstone Flash Storage, which actually includes this signature verification, is cheaper than reading the data from the Chainlink Oracle, which is the most popular Oracle for blockchain nowadays. And of course, these costs doesn't include data write costs, which are really, really cheaper thanks to the affordable Arweave storage. Okay, so let's go to the demo. And if we go to the app.redstone.finance, we can see all the data points that we currently provide, including crypto, mostly crypto, but also stock prices, currencies prices, BST, Avalanche tokens, tokens from the Avalanche ecosystem, ETF indexes, and also commodities like grains, energies, metals, and livestock. And we can do all of this thanks to this scalable model with on-demand fetching. If we go to the Bitcoin, for example, details, we can see the price chart with the Bitcoin prices, which were provided by the Redstone Oracle. On the right side, you can see the sources, the list of sources that were used for fetching the Bitcoin price. We've also implemented this tool to compare the prices for different sources, which can be useful for example, finding arbitrage opportunities. And on the bottom, you can see the list of Arweave transactions that were used to keep these on Arweave. As I've said, we use more than 60 sources now, including DEXs, simple cryptocurrency exchanges, and also like ECB, European Central Banking API, and others. And this application, as I've said, has this interface to manage manifests by providers. So if we click, for example, to the main Redstone provider, we can see a list of provided data with the details containing which sources I used. And providers also have a web interface to interact with their manifests and with the manifest to see the manifest's history. Okay, so let's go to the most interesting part, and let's try to use the Redstone data in our smart contract. I've already prepared a small project with a single smart contract called example and a simple test file, which uses hard hat testing framework. So if I'm a blockchain developer and I want to use the Redstone data, I would go to the npmgs.com and try to find this Redstone flash storage module. Let's type Redstone. We see the Redstone flash storage on the 3rd position. Let's go here. And it starts with the simple explanation that I've already told about. Let's go to the installation section. So the first thing we need to do is to install Redstone flash storage. I won't do this because I've already installed the Redstone flash storage here. So let's move to the getting started section. It contains 2 main parts. The first one is modifying our contracts, and the second one, updating the interface. So let's start with modifying our contracts. The first thing we need to do here is to extend our contract with the price of our contract implementation. So let's simply copy this to our contract code. Okay, and from this moment, we can use the pricing data in the contract code using this get price from MSG method. And we need to pass a single argument here, which is a bytes32 value created from the symbol string. So in our contract, we would like to use Tesla price in USD. And we can go to the prices in the Redstone web app and check that Tesla price is actually available and has the SLA symbol. So we can actually access this price using this method. Let's do this. Let's replace the price here. Replace the symbol. And let's do the same thing here. Okay, so now we need to update this function modifier. Great. One thing that we need to check is that Redstone has 8 decimals in their values, which means that we multiply the values by 100 millions. It's a common approach that Chainlink also uses. So currently we've already prepared our smart contract to use the Redstone data. And the next thing that we need to do is to update our interface. And firstly, we need to import this Redstone flash storage wrapper. Let's do this. And we need to wrap our contract instance using this wrapper builder. And we can select this price feed that we want to use. Let's do this as well. Use wrapper builder, wrap light, where we pass this Ethereum EthersGS contract instance. And the thing we want to do is selecting the price feed that we want to use. We can use the Redstone stocks. It also can be checked on the Redstone application. And we can also specify the asset. In our case, we only need to have the Tesla asset, Tesla price asset, so it should be enough. And now, in every place where we want to access the Redstone data in every function, we need to actually replace this standard contract instance with the wrapped contract instance. So let's do this. Okay, And the last thing that we need to do is the provider authorization, because our smart contract needs to know what providers is trusted and like what Ethereum public address can sign the data that we can trust. And this can be done using this authorized provider method that we've prepared. And this method automatically analyzes the price feed that we provided here and actually uses the appropriate provider Ethereum address. Okay, so now we can call this test using your test. Yeah, and we can see that the provider was authorized and actually that these methods from the contract were called correctly. You can take a closer look on these functions. In the first function, we send a transaction and we update this private variable in the contract state called last price with the Tesla price. The second function doesn't interact with the state. It simply fetches the Tesla price from the Redstone Oracle. And if it's higher, if it's greater than 1,000, then it returns true. And the last price simply returns the value from this contract state. And in the toast code, firstly, we send this transaction, update this price in the contract state. In the second step, we actually call this is overpriced function. And in the third step, we return the value from the contract state. Yeah, so that's how it works. And let's get back to the presentation. Just a few words about traction in our project. As I've said, we already integrated data from more than 60 sources, and more than data for more than 1,000 assets, and already generated more than 1 billion signed data points. Also, our Redstone API, which is a JavaScript wrapper for the Redstone HTTP API, was downloaded 40,000 times since the launch. And we already have a few fully working proof of concepts, including Komodo, which is a commodities trading synthetics protocol built on Ethereum and also built on this Celo blockchain. And we also have a working project, lending protocol on the Avalanche blockchain. Here's our team. We have Kuba, who is our founder and a very experienced technical guy. We have other 3 developers, including me, Piotr, and Piotr. And the first person is also very experienced software developer. And we also have Marcin, who is our head of growth. And of course, as each blockchain team, I think we are going to expand our team. We are currently closing the seed investment round, and we want to find from 10 to 15 new talents. So if you're a good developer or just a good person, so reach out to us. We'll be happy to talk and find opportunities for you. And you can do this using our website. We have a contact form here. So simply go to the redstone.finance, or you can write an email to hello@redstone.finance, or you can join our Discord at redstone.finance/discord and say hi, and we'll be happy to chat with you. Thank you very much. So I'll be happy to answer your questions if you have ones.
When prices are provided by the Oracle, we cannot afford that the delay as other users. Okay, that really depends, because the delay is very intentional for us. So you can actually read data directly from the medianizer without the delay. It's totally up to you. Both of them are provided, and there are some projects that are actually using direct medianizer values if that's required. So I hope this answers the question.
Yeah, guys, so if you have any other questions, feel free to ask them in the chat. We have both Alex and Paweł to answer them. We're gonna give you some time to type that. Well, it looks like we don't have any questions for today. So yeah, guys, thank you very much for joining the meetup today. Next meetup will be in December, second Tuesday of the month. Alex, thank you for the presentation and the live coding session. And Paweł, thank you for being here.
Thanks.
It was a pleasure to host you.
Yeah, it is a pleasure. This studio is nice.
Yeah, so we'll see you next month, guys.
Thank you, guys.
Thank you.
See you next weekend. Bye-bye.